Hello and welcome to this video. My name is David and I am the creator of Polyfoni. In this video we will go over how to use Polyfoni and how to actually compose music. So this video will be an alternative to the user manual that is on the website. So if you don't know what Polyfoni is, I suggest you go to the website, which is polyfoni-app.com. Here you can read a bit more about the application, and there's also like an introduction video kind of thing. I suggest you go here first. This video will be split into multiple episodes covering different topics because it might become a long video otherwise. So in Polyfoni, we create multiple melodies. Whenever we want two notes to overlap or be played at the same time, they have to come from two different voices. What that basically means is that when we have a voice like this one, this is a voice, okay? So you can see it says voice 0, and the voice, it consists of framework and decoration. This is a single voice, and in this voice we cannot have overlapping notes. So basically from this voice we will create a melody, and by having multiple melodies overlapping each other, that's how we get harmony. So a voice consists of multiple tracks. So as you can see here, and this is the timeline by the way, we have beat 4, beat 8 and so on. But a voice consists of multiple tracks. So this first track, this is not part of the voice, this is just a tempo track. Then there's this track here next to the name of the voice, and this is the output track. This is where the melody that we create will be displayed. Then we have the pitch track. This is used to derive the scale degrees that the melody will contain. If you don't really know chord theory / scale theory, I suggest that you go and watch some videos about chords and scales. The pitch track is used to derive the scale degrees of each note. Then there's the duration track that is used to derive the duration of each note. Then there's the rest track that is used to derive whether or not the note should be a rest or a regular note, so an inaudible break in the melody. And then there's the harmony track, and the harmony track works together with the pitch track. On the harmony track we specify scales. Basically the result of the pitch track will be interpreted in the scale that is specified here. Then there's the decoration group. I think we will take that in the next episode. So let's just start with the framework. So what do we do when we actually want to create the framework of the melody? Well, we can highlight tracks, as you have already seen, just by clicking and dragging. So we can just click and drag and press insert on your keyboard. Or you can alternatively go to edit and click create items. But yeah, these are items. What is an item? An item is basically an interval. It's an interval that contains some data. So for the pitch, duration and rest track, this data will be Python expressions, and for the harmony track it will be a scale. So as you can see right now, they don't contain anything, and the harmony or the scale item we created, it just says undefined because we haven't chosen a scale here. So what we can do is we can we click an item, and as you can see here in the bottom of the window, there's an editor that comes up. So you can see for these 3 items, which are string items that contains any text, but they should contain Python expressions, you can just enter some text here. And for the scale item, we can select a scale here, and we can select a scale by clicking on these different pitch names. And you can also see that each scale pattern has a decimal. That is basically just a number that represents the scale pattern. So I think we will go more in depth about scales later. Let's talk a bit about expressions. So let's see what we can input into a duration item. As it's Python expressions. If you don't know Python, well, you should learn that first as well before you come back to this video. Python is a programming language, but it's not a difficult programming language. It's actually pretty simple. So I recommend that you go learn Python syntax, but basically we can input mostly what you would expect to find in regular math expressions. So for example, we can say 1 plus 2. That gives 3, obviously. So now we have defined the duration of each note as 1 plus 2. We can then say, let's say the pitch is just 0, scale degree 0, remember that's the scale degree. And then the rest has to be a boolean, so that means true or false. If it's false, the note will not become a rest. If it's true, the note will become a rest, which means it will not be audible. So if we set it to false, you can still see that no notes have been generated here yet. But once we define a scale, let's select a minor scale, A minor triad scale, sorry. So that's the A minor triad if we try to listen to it. Yeah. Now you might see this looks kind of weird right now, but that's because we are only these are basically our notes right now, and we have 4 notes. You might wonder, you can see each of these notes actually is 4 beats long, and you might wonder, but we defined the duration as 1 plus 2, which is 3. Why is it then 4? That is because duration gets quantized, which means it can only be values such as 1, 2, 4, 8, 16, and also 0.5, 0.25, 0.125. So regular note values. Basically, it will be quantized to duration values that exists in the regular notation system. But let's just try a different value here. Let's set it to 0.5, and now you can see this actually. Now each note is 0.5. So let's try to play a bit. Yeah. Okay, so that's really boring. And that's because the pitch is 0. So for each of these notes, the pitch gets evaluated to 0, or the scale gets evaluated. The scale degree, which comes from the pitch track, gets evaluated to 0. The scale degree 0 in the A minor triad scale is A. So you can see each of these is an A. Now let's say we change what the scale degree is here. Okay, so now you can see from 0 to 8, the scale degree is 0, which is A, and from 8 to 16, the scale degree is 1, which is a C in the chosen scale. Yeah, so now you can see the notes, actually the pitch of the notes change, but that is because we changed the item. Now that is not so interesting, because that would mean that we would have to specify a new item every time we wanted a different pitch, and that is not the intentional use of polyphony. The purpose is that we can specify a pattern for the pitches. So what I mean by this is, in polyphony there's a special variable named x that we can use in expressions. This special variable will require a little bit of explanation, but let's just try what we can do with x. So for example, if I just set this expression to x here, you can see that basically the melody goes up 1 scale degree every note. So let's try to hear this. Yeah, and it will keep going up until basically infinitely. Now we can also do negative x. We can do that in the next item. So now this goes down infinitely. Yeah. Let me explain how x works. You might already have guessed it based on these examples, but let me just explain visually how x works, because that's really important to understand when you use polyphony. So we have x, and we have each note that gets generated. We have here 7 notes, and this is x in a given item. So remember, this is an item. For every note within that item, okay, so for the first note here, x will actually be 0, For the second note, x will be 1. For the third note, x will be 2, 3, 4, 5, 6, and so on, within the item containing the expression. So that is why we get a rising melody, and when we do the negative, the result is actually just negative the numbers that we did. So x is actually what we in programming, which you might know, call an index. So x is the index of the note within the item. An index is basically like assigning a number to each note according to the sequence of the notes. Now, it's not so interesting just to do rising and falling melodies using x, but that is where functions comes in. So basically Python, the functions that are available, I hope you know a bit about Python, but the functions that are available you can find in the user manual. If we go to expressions, where is it? Here. Yeah, so you can see here, this mentions what functions are actually available. So you can just go to polyfoni-app.com/user manual, and these functions here are available, as well as every Python math module function. So for example, pi, the number pi, is available to use within the expressions. So that's how we can create something more interesting. Now there's also some stuff I haven't written here yet, which is the Python random module is also available, so you can do like random notes. And then there's also some other stuff that I might explain later in this tutorial. Let's see what function we can use. So for example, we can use a sine function, and this is one of my favorites because it's a wave function. So let's try to see what happens when we say sine of x. Let's just get rid of this item. So as you can see, this creates a wave pattern in the melody. It gets more interesting, right? Now what we can do is we can just add more stuff to this. We can add as much to this equation or this expression as we want to create an interesting melody. So already now it's getting kind of more interesting. That's kind of interesting. Now this is just the pitch. Remember, we can also use x within the duration item. It's one of my favorite ones to do in the duration item with x is Python list indexing. So if you don't know what that is, just search Google for Python list indexing, and here we can write some values. So we can say 1, 1, 0.5, 0.5, 0.5, 0.5, and then we can say x modulo 6. This means that we will choose these values and then repeat that choice. So the first note will have 1, as you can see. The first note becomes a 1, duration of 1. The second has a duration of 1. The third has a duration of 0.5. The fourth has 0.5. So 0.5, 0.5, 0.5, 1, 1. So it repeats this pattern in the duration. So now we have kind of created a rhythm using that kind of expression, which is list indexing. And then for the rest, we can do something like, if we want to use x, we can say if x modulo 4, that means if the remainder of x divided by 4 is, and then we can just do some number, 0 for example. If the remainder of x divided by 4 is 0, then it will become a rest. So you can see the first note becomes a rest, and the fifth note, and so on. So let's try to listen. Okay, so that turned the notes into rests. Now we can also change the harmony during the melody. So far we've only been using the A minor triad scale. Let's try to use a D minor scale. So here it actually changes the harmony halfway through the melody. Yeah, so it's actually the same pattern, but it's just in another scale. We can change any of these expressions during the melodies. So for example, let's say we want to change durations here for this section of the melody. We can do 0.5. So in this time span, the duration will always be 0.5, and then we return back to this. So I hope that kind of makes sense, that we choose different expressions and scales across time, basically across different intervals, and for every note the expression gets evaluated and x is replaced by that note's index in the item. So that is how we can create variation across time with polyphony. Actually, maybe we should go over some of the functions that we can use. So I mentioned that all the functions from the Python math module is actually available to use. So we have already used one of these, and that is the sine, I believe. Yes, sine. So that's kind of where the creativity comes into polyphony, is how you choose to use these different functions that are available. But for example, there's pi. That is really good, because if you want to have a repeating wave in the melody, we have to say x times pi divided by some, for example, 8. And then let's just simplify this to 0.5. Let's set rest to false. This will actually let's divide by 4 here. This will actually create a wave pattern in the melody that spans 8 notes and then repeats. And this is possible because we use pi from the math library, and by doing that we get an even wave in the melody. So that is kind of the basics of the framework. Now we also have stuff like random. So basically random is a module in Python also. So if we search Python random module, yeah, these are the random functions. It's not all of them that are included in polyphony, but most of them, the useful ones are included. So for example, the basic one, the random one, and choices and stuff like that. But there's a twist. So these functions, if we click on the random one, you can see actually it doesn't take an argument, but in polyphony every function from the random module, it requires you to input x as the seed. But this basically creates random. We can say times 3 or something. Or we could use something like choices, and I believe we have to do no. Let me go to choices and see. Oh, it's choice. It's choice. Yeah, so here it chooses from one of these scale degrees. But again, if we go to choice, we only have to input a sequence actually. But in polyphony you have to input x as the first parameter, and that is just required because we want to get the same generation each time. So very important, whenever you use a function from the math or the random module, sorry, just the random module, you have to input x into the function. Yeah, that's kind of interesting. And just be aware, when you use the random module, you have to input x as the first parameter. But otherwise, just to summarize, you can use all of these functions, and then there's the random module, which you can also use. And then there's the default Python stuff that was listed in the user manual, all this stuff. So that is expressions summarized. There's a lot of interesting stuff you can do with expressions, and that's kind of how we create interesting sections in the music and create different motifs. That is by using expressions. Now I think we will end this episode here. In the next tutorial video we will talk about the decoration group, which will add a lot of interest to our melodies. So I hope you're ready for that. And yeah, see you then. Thank you for watching.